All right. Let's dive into something truly mind-bending today.
Okay.
You know how a wrench would just keep drifting in space if you gave it a push?
Yeah.
That's inertia,
Right.
a resistance to change in motion.
Mm-hmm.
But what if energy itself, the stuff that makes up light and heat and powers the universe,
Yeah.
also had inertia?
Interesting.
We're talking about potentially unlocking the secrets of dark matter and dark energy,
Wow.
two of the biggest mysteries in the universe.
Yeah.
Are you ready to have your mind blown?
I think so. I hope so.
Okay.
It's a truly fascinating concept.
Yeah.
We usually think of inertia as being tied to something tangible like mass.
Right.
But the idea that energy,
Yeah.
something often perceived as formless, could resist changes in motion like a physical object is revolutionary.
Okay, so to really grasp this,
Yeah.
we need to go back to Einstein's famous equation,
Right.
E equals mc squared.
Right.
It tells us that mass and energy are basically two sides of the same coin, right?
Exactly.
Yeah.
And we see this in dramatic ways.
Yeah.
Like in nuclear reactions, where a tiny amount of mass can be converted into a tremendous amount of energy.
Right.
But the equation works both ways.
Okay.
Energy can also exhibit properties
Yeah.
we typically associate with mass.
So like with light,
Yeah.
it doesn't have mass in the traditional sense,
Right.
but it can still push things. Like those solar sails that use sunlight for propulsion.
Exactly.
That's pretty wild.
It is.
But does that mean light has inertia?
Well,
Is it resisting changes in its motion?
that's the key question.
Okay.
Just because energy has momentum,
Yeah.
the ability to move and exert force
Right.
doesn't automatically mean it has inertia.
Okay.
That resistance to change in motion.
Right.
This is where things get really interesting.
Okay.
And it leads us to one of the biggest head scratchers in physics,
Ooh. Okay.
the cosmological constant problem.
Lay it on me. What's this problem all about?
Well, quantum physics predicts a massive amount of energy
Okay.
in the vacuum of space.
Right.
We call it zero-point energy.
0-point energy.
But when we try to actually measure this energy,
Okay.
the value we observe is mind-bogglingly smaller. It's off by a factor of 10 to the power of 120.
Wow.
A number so huge, it's almost impossible to comprehend.
Okay. That is a huge difference.
Right.
So where is all that energy going?
Yeah.
Or is it even there at all?
That's the million-dollar question.
Yeah.
What if this missing energy actually has inertia? Could that explain why we're not seeing its full effect?
Interesting.
If this vacuum energy resists changes in its state,
Yeah.
like expanding or contracting,
Uh-huh.
it might account for that enormous discrepancy.
So it's like this vacuum energy is a bit stubborn.
Yeah, you could say that.
It doesn't want to play by the rules we expect.
Exactly.
That's a pretty radical idea.
Yeah, it is.
But I'm curious, how does all of this connect to dark matter and dark energy? Those cosmic mysteries everyone's always talking about.
That's where this idea gets really exciting.
Okay.
Imagine this. What if, instead of needing to invent new particles
Right.
or forces, we just need a better understanding of the energy that's already there?
Interesting.
Yeah.
Okay.
Yeah.
So, yeah. All right, well, all yours. How could this stubborn energy, this energy with inertia, explain something like dark matter?
Okay.
It's supposed to be this invisible stuff holding galaxies together, right?
Exactly. We see galaxies rotating way faster than they should,
Yeah.
based on the amount of matter we can see.
Right.
Stars, gas, dust.
Uh-huh.
There's got to be something else there,
Yeah.
providing the extra gravitational pull
Right.
to keep them from flying apart.
Yeah.
That's what we call dark matter.
Right. The invisible cosmic glue.
Yeah.
But for a long time,
Uh-huh.
people have been searching for some new undiscovered particle to explain it.
Exactly.
Yeah.
And that's still a leading theory. But what if dark matter isn't about new particles at all? What if it's about this inherent inertia of energy we've been discussing?
Wait, so you're saying the energy itself,
Yeah.
maybe that vacuum energy,
Right.
could be mimicking the gravitational effects of dark matter?
That's the idea.
How would that even work?
Think of it like this.
Okay.
Imagine this energy with inertia
Yeah.
as a kind of cosmic molasses
Cosmic molasses.
spread throughout the universe.
Okay.
This molasses resists the motion of galaxies,
Huh.
creating a sort of extra drag.
Okay, so it's not that there's more mass,
Right.
but that the existing mass is encountering this resistance
Exactly.
from the energy itself.
Yeah.
That's a really cool way to think about
It
it.
is pretty wild.
But what about dark energy?
Yeah.
That's the force that's pushing everything apart, right?
Yes. And that's another puzzle.
Okay.
The universe's expansion isn't just happening.
Mhm.
It's actually speeding up.
Right.
And dark energy is the name we give to whatever is causing this acceleration.
And the current thinking is that empty space itself has some kind of pressure that's driving this expansion.
Right.
But nobody knows where that pressure comes from.
It's one of the biggest mysteries in modern physics.
Yeah.
But here's where the idea of energy having inertia gets really mind-blowing.
Okay.
What if, as the universe expands, this vast sea of vacuum energy with its inherent inertia is actually pushing back?
So instead of some mysterious outward pressure, it's the energy itself resisting the stretching of space.
Exactly.
That's counterintuitive.
I know, right?
Yeah.
Think of it like this.
All right.
Imagine trying to stretch a sheet made of rubber bands.
Okay.
The more you stretch, the harder the rubber bands resist.
Okay, so maybe the universe is like a giant sheet of cosmic rubber bands.
Yeah, like that.
And dark energy is actually just the resistance of those rubber bands to being stretched. And that resistance actually causes the universe to expand even faster.
That's the idea.
I think I'm getting whiplash from all these mind-blowing ideas.
I know. It's a lot to take in.
It is.
But what's fascinating is that this single property of energy, this inertia, could potentially explain but the cohesive force we attribute to dark matter and the expansive force we call dark energy.
So are you saying we might need to completely rethink our understanding of gravity itself?
Well,
like maybe Einstein's general relativity, our current best theory, is missing something crucial.
Einstein's theory has been incredibly successful in explaining gravity.
Right.
But it's not without its limitations.
Okay.
Especially when we start talking about the universe on its largest scales.
Yeah.
There might be more to the story.
Are there other theories out there that could potentially incorporate this idea of energy having inertia?
Yes, there are alternative theories called modified gravity theories.
Which propose that gravity might behave differently at vast cosmological distances.
So could these modified theories accommodate the idea of energy having inertia?
Yes.
And its potential effects on dark matter and dark energy?
Absolutely. If energy has inertia, it could subtly alter the way gravity works over very large distances.
Right.
It might slightly change the curvature of space-time. Leading to subtle effects that could explain both the clumping of matter we see in galaxies and the accelerating expansion of the universe.
This is incredible, but how do we actually test this idea? It all sounds pretty theoretical.
Well, there's good news.
A
new generation of space telescopes. Like the Euclid Space Telescope.
Euclid Space Telescope.
And the Nancy Grace Roman Space Telescope.
Wow.
Will soon be giving us the most detailed map of the universe ever created.
So we're going to have a much clearer picture of how galaxies are distributed.
Exactly.
And how the universe is expanding. And if this idea of energy having inertia is correct, it should leave subtle but detectable fingerprints on these large-scale structures. We might see slight variations in the distribution of galaxies or subtle anomalies in the way the universe is expanding.
Right.
That wouldn't be there if gravity worked exactly as Einstein predicted.
Okay, so we just need to wait for these telescopes to start gathering data. And then we might have the evidence to support this mind-blowing idea.
Exactly.
That is truly exciting. So where do we go from here? So we've gone from a simple question, what if energy has inertia, to potentially rewriting the laws of physics.
It really is amazing.
It is.
How one seemingly simple question can lead us down such a profound rabbit hole.
Right.
But that's the beauty of science. It's
Right.
all about pushing the boundaries of what we know and exploring the vast unknown.
Exactly. And in this case, the unknown we're exploring is truly mind-boggling.
It is.
We've talked about how energy with inertia might be the key to understanding both dark matter, the invisible glue holding galaxies together, and dark energy, the mysterious force pushing the universe apart.
And what's truly remarkable is that this idea, as wild as it sounds, could potentially tie together these two seemingly disparate phenomena under one elegant framework.
Right. Instead of needing exotic particles or strange new forces.
We might just need a better understanding of energy itself.
So to recap, we started by looking at Einstein's famous equation. E equals mc squared.
Right.
And how it shows us that energy and mass are fundamentally connected.
We talked about how light, despite having no rest mass, can still carry momentum and even bend around massive objects.
Right.
Due to the warping of space-time.
And that led us to the cosmological constant problem, this enormous discrepancy between the amount of vacuum energy predicted by quantum physics and what we actually observe.
The idea that this missing energy might actually have inertia could explain why we're not seeing its full effects. It's like it's resisting our attempts to measure it directly.
And then we took a giant leap.
We did.
And explored how this same inertial energy could be responsible for both the clumping of matter we see in galaxies and the accelerating expansion of the universe.
It could be the hidden force behind both dark matter and dark energy.
And the best part is...
What's that?
That we might be on the verge of actually testing this idea.
I know. It's very exciting.
New space telescopes like Euclid and the Grace Roman Observatory will soon be giving us incredibly precise maps of the universe.
And these maps could reveal subtle clues about the distribution of galaxies and the rate of cosmic expansion, which could provide evidence for or against this idea of energy having inertia.
Exactly. The data from these telescopes,
I know, this could be incredible,
could potentially revolutionize our understanding of the universe.
It's an incredibly exciting time to be studying cosmology.
So what does all of this mean for you, dear listener?
Right.
Well, the next time you flip on a light switch or feel the warmth of the sun, take a moment to consider the profound mystery of energy.
It's not just something that powers our homes or fuels our cars.
Right.
It might be the very fabric of the cosmos, a force shaping the universe on scales both vast and tiny.
We're just beginning to understand its true nature.
Yeah. And the idea that energy might possess inertia could be one of the most significant discoveries in the history of physics.
Yeah. It could change everything we thought we knew about the universe and our place within it.
We're at the frontier of a new era of cosmic exploration. And who knows what incredible discoveries await us as we continue to probe the deepest mysteries of the universe.
So keep those questions coming, keep that curiosity alive, and never stop exploring.
Because the more we learn about the universe, the more we realize how much more there is to learn.
And that's the beauty of it all, isn't it?
It is.
The journey of discovery never truly ends. Thanks for joining us on this deep dive.
It was my pleasure.
Into the mind-blowing world of energy, inertia, and the mysteries of the cosmos.